This video is a review for Quiz 1 of Unit 1 in Geometry. So in the first 4 questions for true or false, number 1, A, K, and U are collinear. So point A, point K, and point Q, are they collinear? Well, to be collinear, that means they all need to be on the same line, but A is not on the same straight line as K and U, so this would be false. In number 2, D, M, and A are collinear. Well, they are on the same straight collection of points, so that would be true. They are collinear. In number 3, angle ARU and UGR are on the same angle. Well, if we use it without even looking at the picture, if we notice the middle letters, they're not the same, which means they don't have the same vertex. So this is false. Number 4, there's a line that passes through R and K. So even though there's not a physical line drawn on the page, remember any 2 points form a line. So this is true. Remember that 2 points form a line always. So even if it's not drawn. Number 5, identify the points that are collinear with DM. Well, DM is on this line together. So the other points that are also on it would be A and S. Make sure you separate your points with a comma. If you write them together, that means something different. Number 6, name DK, line DK in a different way. So line DK actually has 3 points. So to name it, to rename it, we can switch the order of DK, or we can put U in place of one of those letters. So if I put U in place of D, I would have KU or UK. And if I put U in place of D, I would have DU or UD. In number 7, given the points G is at -4, 5 and B is at 4, 7, find the midpoint of GB. Well, if GB is the segment, those are endpoints. So to find your midpoint, you're going to use your midpoint formula, which is x1 plus x2 divided by 2 and y1 plus y2 divided by 2. So our x coordinates are -4 and 4. So -4 plus 4 divided by 2. Our y coordinates are 5 and 7. So 5 plus 7 divided by 2. So to simplify, -4 plus 4 is 0, divided by 2 is 0. And 5 plus 7 is 12, divided by 2 gets us 6. Now, in number 8, we're switching. G is the midpoint of segment AB. We don't have an A up here, so that's why we're going to find coordinate A. So remember that B here is our endpoint, and G in this case is our midpoint. So when we are trying to find another endpoint, we need to set up a table. So with our x, y coordinates, we are going to go endpoint that we know, midpoint that we know, endpoint that we are looking for. So if our endpoint we know is B, B is at 4, 7. The midpoint we know is -4, 5. We're looking for the other endpoint. So we're using our jumps to see how the x and y have changed. So to get from 4 to -4, we subtracted 8. When we subtract 8 again, we get -12. For y, we go from 7 to 5, so we can subtract 2. When we subtract 2 again, we get 3. So A has the endpoint then of -12, 3. In number 9, we have points G at -4, 5, B at 4, 7, and S at 8, -7 that form a triangle. Draw the triangle, then answer the following question. So G is at -4, 5, B is at 4, 7, and S is at 8, -7. So we're going to connect those points for our triangle. In part A, it finds find the slope of GS. Well, GS is going down from left to right, so we should have a negative slope. So I'm going to create my slope triangle so I can figure out what my rise and run were. And I can do that by counting how many did I go down to get with S, and then how many did I go over to get to S. So from G, we went from 5 to -7, so we went down 12 if I count my grid lines. And then to go over, I went from -4 to 8, which is +12. So my slope is rise over run, so -12 over 12, which gets us a slope of -1. In part B, or part C, we want to find the distance of GB. So the distance formula is x2 minus x1 squared plus y2 minus y1 squared. So the x coordinates that we are subtracting are 4 and -4. So 4 minus -4 squared plus, we're going to subtract the y coordinates, 7 minus 5 squared. Remember that you can put them in either order in the parentheses, because when we get to the next step, it's going to be the same. So we have 8 squared plus 2 squared. You might have different signs if you put them in different orders. So we get 64 plus 4, which is the square root of 68. 68 is not a perfect square, which means we need to use our calculator to get a decimal. So we would have 68, and we do the square root. That's going to be 8.25. In number 10, we want to solve for x and find AY. So there are 3 segments that equal our whole segment. So we have 3x plus 12 plus 4x minus 2 plus 5x plus 8 is equal to 78. So when we combine our x's, we have 12x, and when we combine our constants, we have plus 18 is equal to 78. So we can subtract 18 on both sides. 12x equals 60. We divide by 12, x is 5. Then to find AY, so AY is these 2 segments put together. So we're going to substitute 5 into both places. So 4 times 5 minus 2 gets us 18, and 5 times 5 plus 8 gets us 23. So AY is going to equal 18 plus 23. So AY would have a length of 41. In number 11, A is between M and N. So if we have M and N, between does not mean directly in the middle, so I'm going to put A a little bit closer to M. MA is 9 minus 5x. NA is 41 minus 3x. And our whole length, MN, is 46. So when you are solving using segment addition, we want to add those 2 smaller pieces equal to the whole thing. So 9 minus 5x plus 41 minus 3x equals -46, or 146. When we combine, we get -8x plus 50 is equal to 146. We can subtract 50 from both sides, so we get -8x is equal to 96. And when we divide, we get x is -12. Now, it's okay to have a negative sometimes for x, especially because we are subtracting the x, which means it's actually going to be a positive when we substitute in. To find AN then, we know that AN is 41 minus 3x. So we have 41 minus 3 times -12, which gets us 41 plus 36, which is 77. In number 12, A is the midpoint of CT. So this time, that means A is going to be in the center of our line and bisecting it into 2 congruent parts. We know that CA is 4x plus 4. and CT is 22x minus 40. Now, in this case, you only have half the line and the whole line. So remember that you need two halves to equal a whole. So we're going to have 2 times 4x plus 4 is equal to 22x minus 40. So we get 8x plus 8 is equal to 22x minus 40. We have 22 minus 8 is 14x. And when we add 40 to both sides, we get 48. So when we divide 48 divided by 14, it's going to be a decimal. So in our calculator, 48 divided by 14, math, enter, enter, and we get 24 over 7. So x equals 24 over 7. Sometimes x is going to equal a fraction. To find AT, well, since AT is congruent to CA, we know that AT is 4x plus 4. So AT is going to equal 4 times 24 over 7 plus 4. So we can use our calculator. 4 parenthesis 24 divided by 7 plus 4. Math, enter, enter. So we get 124 over 7. In number 13, O is the midpoint of DG, which means that these two pieces are congruent. Solve for H, and then find DG. So this time, these two halves are congruent. So if we have a half is equal to a half, we can set them equal. So 9x minus 10 is equal to 4x plus 10. So we can subtract 4x from both sides, so we get 5x, and we can add 10 to both sides to equal 20. When we divide, we get x is 4. Then to find DG, we can substitute into both pieces to find our whole length. So 4 times 9 minus 10 is going to get us 26. 4 times 4 plus 10 is also 26, which makes sense that those are equal because it was a midpoint. So DG then is going to equal 26 plus 26, which is 52. In 14, given that SB is 6x plus 17, GJ is 7x minus 1, and CL is 10x minus 50, if SB is congruent to GJ, is CL congruent to SB? So, first of all, we know that SB is congruent to GJ. So we're going to set those equal. 6x plus 17 is equal to 7x minus 1. So as we solve, we get x equals 18 because we can subtract 6x from both sides and we can add 1 to both sides. Once we know x is 18, to figure out if CL is congruent to SB, we need to look at their lengths. So SB, we can substitute in 18. 6 times 18 plus 17 gets us 125. When we substitute in a CL, 10 times 18 minus 50 is 130. So in this case, they have different lengths, so they are not congruent. So no, SB is not congruent to CL because the segments do not have the same length. In 15 through 18, we want to name the figures correctly. So in number 15, this is a line. With a line, you can use 2 letters. So we could have BU is one line with the arrows. We could also have SB. There's multiple other choices that you could have as long as you have two letters in any order, it doesn't matter. In 16, we have a plane. So in a plane, you can name it with three letters. So we can name it CAR, or you can name it with a cursive letter. So we can name it with that cursive S that's in the corner up there. In 17, this is a segment because I have a start and end point. So your start and end point must be the two letters you use, but the order does not matter. So we can have DR or RD with our segment bar above it. 18 is a array. So in an array, it is important that the name starts with the endpoint. So we could have DR. Remember, we're always pointing to the right still. Or we could have DQ. You can use any other letter that's on that array, but D must be the first letter.